our lesson video today, we're going to go through some of the division strategies that are used in Key Stage 2. Now I'm going to introduce the strategies starting from year 3 and working up to year 6. It is important to remember that obviously every child is individual. You may have children in year 5 and year 6 that need to use the strategies from the beginning. Perhaps they haven't consolidated things, or you may have children in year 3 or 4 that can actually move forward. But I'm going to show you some of the division strategies from the very beginning, working up, and you can decide where to pitch that then with your child. So if we start with year 3 and 4 and what you need to know. In year 3, your children are expected to know their 3s, 4s and 8 times tables. This is building on from the 2s, 5s and 10s earlier on in year 2. They're also expected to be able to recall the division facts. So if they know that 3 times 4 is 12, they should be able to know that 12 divided by 4 is 3 and 12 divided by 3 is 4, etc. In year 4, those division and times table facts actually extend to the whole of the times tables up to 12 times 12. So in year 3, they're also being introduced to some formal division methods, dividing 2 digits by 1. And in year 4, they're starting to use those written division methods more consistently. In year 3, they're starting to solve division problems, and in year 4, they are continuing. I can't stress how important multiplication grids are. I find that they get used less and less now, but they are really useful. It helps children to understand the link between times table facts and division, and it supports that rapid recall. If they're used to looking at one of these and they get familiar with it, it does actually start to just embed in their head. And we all know that sometimes you just know facts. You're not sure how you know it, you just remember it somehow. So as many ways children can get involved with the times tables is brilliant, basically. TT Rockstars is fantastic if your school has access to that. But use the times table grid to help children to figure out how to find a times table fact and how to use it with a division fact. So for example, if we take 6 times 5, we can go down to the 6 down the left hand column and the 5 at the top. We can go down to find 30, but we could also use the 5 on the left hand side and the 6 at the top. It's also 30. This is because it doesn't matter which way round we use our 5 and 6. When we are multiplying, we can switch the 2 digits round and it doesn't make any difference to the answer. Now, if we were to use that with a division question, if I was to say what is 30 divided by 6, I could go to either of the 6's on the left or the top. I'm going to go down the left, go along till I find my 30, and if I then head up, that gives me my answer of 5. It also works if I was to go to the 6 along the top, go down to my answer of 30, and then go left to find my answer of 5. Okay, so let's take another fact. I can see on here that 9 times 8 is 72. So I've highlighted the 72 on the grid there. If I was asked what 72 divided by 8 is, I could simply go along to my 8, down to the fact 72, and go along to the side, and my answer is 9. I have put in the links, a link to some of these multiplication grids. I'm doing those free for you. So if you click on that, download that, you've got the grid which you can use to practice times table recall and division recall. I've also got some blank ones, so you could print the blank templates off. Your children, you could give them a set time, 10 minutes for example. How many facts can they complete in 10 minutes? Can they keep improving that over time? Or it might be let them finish the whole thing. How long did it take them? Can they improve their time? And there's also 3 challenges in there. So there are some that are a bit more tricky than just the standard layout. So print those out and give those a go. Okay, let's look at division. When we divide, we are sharing equally, and it is really important to understand that when we divide, we have to share equally. We're going to take a simple problem to start with, and that is that 10 divided by 5 is 2. Now, when we divide by a number, in this case 5, we can do 2 things. We could find 5 groups. So, for example, we could do our 5 groups, and I'm going to count 10, and I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm going to check that they all have the same amount in them, which they do, and I can see that in each group there is 2. So when sharing my 10 into 5 groups, each group has 2 in it. The next thing we can do is to share into groups of 5. So here I would make a group of 5 and then make another group of 5. I've got 10 now, I can't make any more groups of 5. There are 2 groups of 5. My answer is 2. Now I prefer to divide into groups rather than groups of. So if I'm dividing by a number, I would use that divisor as how many groups. So with 10 divided by 5, I would put that into 5 groups. Now this will then also work with a bar model, which some of your children may use at the school. It's important to note that all schools do different things. Some schools follow White Rose, some schools follow Inspire Maths. There's no problem maths. There's lots of different math schemes out there. So your child's school may follow certain methods, and I know the biggest concern with parents is that we don't want to confuse them with the methods that we know when they're learning different ones. So I'm going to show you as many of them as I can so that you can understand a method that they may be using. So here is our bar model. So I've got a bar and I've split it into 5 sections. So that's my 5 groups. So as with the circles earlier, I'm going to share the 10 equally. Okay, so we're going to share our 10 into the 5 sections. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I check that each section has an equal amount, which it does, and I count how many there are in just one section. My answer is 2. This is another way that you might have a bar model visualized. Rather than the bracket on top, you might also have another bar, and it's showing that the 2 bars, the top and the bottom, are both equal to 10. The top one is one section, the bottom one has been split into 5 groups. Okay, let's move on to a more complicated question now. 5 children collected 30 Easter eggs altogether. They decided to divide their eggs up equally. How many did each child get? Now, with division problems, a lot of the time children have to figure out that what they're needing to do is divide. Now, if they're doing a division lesson in school, it's obvious they need to divide, but it is important that sometimes children are given questions about division without knowing that they are testing their division skills that day. So if children can get used to reading a question, deciding, right, I need to divide here, or I need to add here, or I need to multiply here. But let's have a look at how we might solve this question using a variety of methods in lower key stage 2. So the first one we used earlier was just putting them into 5 groups, because the question that we are doing is 30 divided by 5. So 5 is my divisor. I'm going to use 5 groups, and I'm going to tally 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. I've got an equal amount in each group. I look at one group, I'm going to look at that group there, and I have 6. So my answer is 6. Let's have a look using the bar model. Now, with the problem I've just demonstrated, it can take quite a while if you're going to count up in ones. So once your child gets more confident, you could encourage them to count up in 5s or 10s. Now I can't count up in 10s here because there's 5 sections, and if I put 10 in each section, that would be 50, which is more than I have. So I'm going to count up in 5s, and I'm using place value counters here. Some of your children may use these in their schools. So I'm counting up in fives. 5, 10, 15, 20, 25. If I carry on counting up in fives, 30. I've completed the 30, however, you can see it's not equal in each section. So that last 5, I'm actually going to swap that for 5 ones now. So I got to 25, 26, 27, 28, 29, 30. I can clearly see that there are equal amounts in each section. I've used up my 30. I'm going to look up what's in one section, and that's 6. So again, as before, my answer is 6. Let's take a look at another way of doing it. Let's take a look at another question. So this time I'm going straight to my bar model. 5 children again have collected 95 Easter eggs, and they've decided to divide up their eggs equally. So again, I've got my 5 sections, but this time I've got 95 to share. So this time I'm actually going to start by counting up in tens. 10, 20, 30, 40, 50. Now I don't have enough to count up in tens again. Now your children may count up in tens again and realise when they get to the 4th section that there isn't another 10. At that point, you can then, it doesn't matter, you can take those out and then think about, can I count up in fives? 55, 60, 65, 70, 75. And again, they may carry on with the fives and recognise then that they don't have enough. So we're going to now count up in ones. 76, 77, 78, 79, 80. 81, 82, 83, 84, 85, 86, 87, 88, 89, 90, 91, 92, 93, 94, 95. Okay, I've counted up my 95. You can see there is the same in each section. So we now just need to count what's in one section. I've got a 10 and a 5, which is 15. 16, 17, 18, 19. So my answer is 19. Let's have a go at doing that using another method. Now this is an introduction to the bus stop method. Most of us adults are used to putting a division into a system like this. It's sometimes referred to as the bus stop method because it looks like the 95s and a little bus shelter there. Now to introduce your child to this concept, we want them to be understanding that that 9, for example, is actually 90. So we're going to use place value counters again. I'm going to swap my divisor for a 5 and I'm going to, because I'm dividing by 5, I'm going to split my 95, that area, into 5. So I'm going to put 5 lines across like this. Now I'm going to start with the 9 and I'm going to swap that 9, which was a 90, for 9 place value counters that all have a 10 on them because it's showing that that was actually a 90. And I'm sharing them into the 5 rows. Now my 5, which is 5 ones, I'm going to swap that for 5 1 counters and I'm going to share them across the 5 rows. So now I have set out my 95 within the bus stop in the 5 rows because it matches that I am dividing by 5. So now I'm actually going to begin to divide. So I'm going to look at my 10s. Now how many columns do I have? I've only got one complete column, haven't I, there? This column here, it's not complete. So I'm going to need to carry that over. I'm going to actually, because they don't fit they don't completely spread over those 5 rows, I'm going to exchange them. So I'm going to exchange one 10 for 10 ones, another 10 for 10 ones, another 10 for 10 ones, and another 10 for 10 ones. So now I've exchanged all the 10s for ones. You can see that rather than carrying the 40 over next to the 5, I've swapped the 40 for 40 ones, and now I've got 45. But actually, because I've spread them into the rows, I can simply count how many columns I have because they're all complete. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. I have 9 columns. So I put a 9 at the top and my answer is 19. Let's have a look at another way of doing this. So this is the way many of you as adults, if you're an adult watching, will know. So I'm simply going to look at my 5 and think about how many times it fits into my 9. It fits in 1 time and there is a bit left over. There's 4 spare, there's 4 remaining. I take my 4 remainder and I put it next to my 5 and that now becomes 45. And using my 5 times tables, I think about how many times 5 fits into 45. 5 fits into 45 9 times. I can count up in 5s, or I might just remember that 5 9s are 45. So I put 9 at the top and my answer again is 19. Let's take a look at one more method. Now this is short division because it's a number that we can use mentally, so we should know our 5 times table mentally. But also it's short division because we're just carrying any remainders over within the bus stop. However, many schools are starting to use a long division method for numbers which have traditionally been used with short division. So I'm going to show this other method because your child may be using this and it's probably good for you to understand how it works. Similar to the last one, we're going to look at how many times 5 fits into 9. And I'm going to say it fits in 1, so I'm going to write my 1 at the top. But now I actually have to prove it. So I prove it by writing what 5 times 1 is underneath. And it's 5. So I'm writing my proof underneath and then I'm going to subtract it. 9 take away 5 is 4. That's my remainder. Earlier on we carried the remainder over, we calculated it mentally, but with long division you write your remainder underneath by proving it, and then we take our 5 and we bring it down. We've now got 45 at the bottom there, and we say how many times does 5 fit into 45? It fits in 9 times. I write my 9 at the top. And then what you should do is prove that. 5 times 9. And if I take that away, I'm going to be left with 0. As soon as you're left with 0, you're done, you're finished. And the answer is 19 again. Okay, we're going to go through all those methods one more time. This time we're going to look at what happens when there is a remainder in the problem. So this time our 5 children collected 76 Easter eggs altogether. So let's take another look at a few of the different methods. So using the bar model or 5 groups, because we are doing 76 divided by 5 as our calculation. We're going to share our 76 into 5. Now I'm going to count up in tens to begin with. 10, 20, 30, 40, 50. I know I can't continue in counting up in 10, so I'm going to start counting up in 5s now. 55, 60, 65, 70, 75. And I can't count up in 5s, so I'm going to start counting up in 1s. But that 1 is only going to fit in one section. There is no way I can split that up unless I split my 1 up into decimals or a fraction, which we're not going to cover just yet in lower key stage 2. So that 1 that won't fit in becomes my remainder. So I'm going to look at what has been shared equally, and 15 was shared equally, but there is a remainder of 1. So my answer is 15 remainder 1. Let's look at the same question with a different method. So as we did before, we're using our bus stop, but we're going to swap our numbers for place value counters. I'm dividing by 5, so I'm going to use 5 rows. My 7, which represents 70, I'm going to swap for 7 10 counters, 7 tens counters. So sharing them into my 5 rows. You can see that's it. I'm done. I've got no more 10s. I'm going to swap my 6 now into 1s. And I'm going to share them across the 5. And that's it. There's my 6. Okay, I can now begin to actually solve. So if I'm looking at my columns of 10, there's only one column that actually that fills up all 5. So I've only got one full column. Now I've got 2 10s spare. So they need to go over with my 1s. So I need to exchange. I'm going to exchange my first 10 for 10 1s. And I'm going to exchange my second 10 for another 10 1s. And now I'm going to count how many full columns I've got. I have 1, 2, 3, 4, 5 full columns. But I have this one left over. There's nothing else that I can change that down for unless I go into fractions or decimals. So I can write remainder 1. Let's have a look at the short division method that the adults might be more familiar with. 5 into 7. How many times does 5 fit into 7? It only fits once. There is a remainder of 2. There's 2 spare. I'm going to write that next to my 6. And now that becomes 26. How many times does 5 fit in 26? It only fits in 5 times. 5 times 5 is 25, so there's a remainder of 1. And finally, let's look at doing the same sum using the long division method. So 5 into 7 goes 1. But I need to prove it. 5 times 1 is 5. I'm going to take that away. 7 take away 5 is 2. I bring the next digit down. 5 into 26 goes 5 times, but I need to prove it. 5 times 5 is 25. I'm going to take that away. 26, or 6 take away 5 is 1. 2 take away 2 is nothing. So I have 1 left. There are no more digits that I can use unless we go into fractions or decimals, but we're not going to cover that right now. So that is left, it becomes my remainder. So you can see all the methods came up with the same answer, but it's a progression of the methods just for you to get your heads around. Have a go at each of them, or have a go at the ones that you feel confident with. If you would like to move on to the year 5-6 methods, where we're doing more complicated short division methods and long division methods, and also thinking about changing our remainders to fractions and decimals, I have made the division lessons on the Pocket Private Tutor app free. They are not usually free. There's 6 other lessons that are free, but for 1 week only, I am going to make those accessible. So if you download the app, it's available on Android or Apple. It's free to download. There's no time limit on it. It won't start charging you at all unless you physically open a padlock and then pay. At which point, if you want to do that, it's only $4.99 a month. But you can access the short and long division method lessons and activities with past stats questions on Pocket Private Tutor for 1 week from starting today. I hope you've enjoyed this lesson, and I'll be back with more tomorrow.